END-O-SLUG is a project that is part of a European framework, FP7, the 7th framework program. And as you can see, the presentation has been prepared by this gentleman from a company, United Utilities in the UK. The aim of the project is to have marketable sludge derivatives from sustainable processing of wastewater in a highly integrated treatment plant. So in simple words, to make an end to the production of sludge in two ways: reducing the amount of sludge produced, and then the remaining sludge turn it into a useful product and not into a waste. That's a very ambitious, extremely ambitious objective, of course, and we have worked to reach this objective together with a group of 15 companies and universities and institutions from 5 countries, the United Kingdom, Ireland, Belgium and the Netherlands, and in Spain. And my company was part of this team. As you can see, we're somewhere in the middle of this slide. The scope of the project, as I have already told you, is very wide. First part of the program is sludge reduction. The second part, sludge treatment, then downstream processing, and then as number 5, the 5th part number 4 is the market development, and number 5, the management and sustainability. So it not only goes about technical issues, but also about legal issues, how to market the product, so also economic issues were involved, a very wide range. The job of Waterloo was limited to only this one bullet within the part number 3, the granulation step. I'll come back to that in a little bit more detail later on. I will talk a little bit about the different steps of the project, although I'm totally out of my competence in these first steps, which is the biological treatment of sludge and the biological treatment of water. But I'll try to do my best. This is a conventional wastewater treatment plant with primary sedimentation, so primary sludge, secondary treatment and secondary sludge, and then tertiary and even advanced treatment. All this sludge goes to an anaerobic digestion for production of biogas, and the remaining product is then called biosolids. And this is a very traditional system. The first part of the process was to remove or to find an alternative for the activated sludge process by an innovative or a special dissolved air flotation device combined with a biosorbent product, a biosorbent step, so an addition of a product that removes the pollution before the tertiary treatment. Of course, if you want to read much more about this particular part of the project, there is a special website. I'll show you it at the end of the presentation, and there's also a lot of documents have been published already, papers have been published by the different parties that were involved in this project. Here you see one particular slide with some information of the results of this dissolved air flotation test done by a Dutch company, and you see that with this system it was possible to remove more than 99% of the suspended solids, and also acceptable COD removal. The second, this is a slide about this sorbent test. Different sorbent products have been tested to remove an amount of COD from the water. And you see here also laboratory results, and you can clearly see the difference between water in and out. In the sludge treatment itself, different aspects have been part of this program: pre-treatment, invert phase fermentation of IPF, digestion, intensification, and competitive exclusion. I'll briefly talk about each of these. In order to improve the digestion of the sludge, it was tested. A new system of ultrasonic sonication was tested in order to see whether it would collaborate or, let's say, improve the enzymatic hydrolysis that was already part of this program. And so different tests were done at universities in Spain, at 2 institutions in Spain, with different types of wastewater. And for those of you interested in this part of the test, again, please refer to the papers. Inverted phase fermentation was tested, or a new system of inverted phase fermentation was tested as a means to separate the liquid and the solid in the sludge. And okay, I think that these tests were reasonably successful. It's especially Dr. Le of United Utilities who's most involved in this part of the program. All with the objective of improving or increasing the amount of biogas from the digestion. So that was again also part of the program. I'm not very familiar with the results of this section of the project. The competitive exclusion part of the program was apparently in centrifugation. There is an increase of the amount of E. coli, or one notices an important increase of the growth of E. coli bacteria in the cake. And this part of the project aimed at injecting within the treatment another bacteria that would compete with this E. coli and thus suppress the growth of this E. coli and this dangerous bacteria in the sludge cake. And these tests were rather successful and done on laboratory scale by one of the partners. Then we come to the downstream processing. So once the sludge has been digested and is centrifuged, normally you have liquid treatment and then land application, like the Professor Menini has already explained in the UK, quite popular approach. What we wanted to do is to use this liquor to do resource recovery, so recover nitrogen and phosphorus, and to turn the sludge into a high quality product which we call an organo-mineral fertilizer. So we wanted to turn the sludge into a product and not a waste that can be then put on the market at a price in competition with other fertilizers. You see here the objectives of this OMF. We wanted it to be a granular, free-flowing, dust-free product in a limited size range and with a guaranteed content of nutrients. Issues, of course, in this are that production of a dry product is energy intensive and creates high wear and maintenance costs, and also creates an explosion risk. The production of this organo-mineral fertilizer, and now we come more to the product of my company, Waterloo. The production of this OMF is a two-stage process. First, we make granules in a machine called the granulator, made by Waterloo, and then the granules are finished or completed in a dehydration unit produced by another partner of this 15-man team, if you want. The pelletizer or the granulator that we have used is our PUTAR technology. I'll briefly explain how this machine works. The wet sludge is pumped to a coater. In the coater, the granules, the dried granules, are recycled and receive a new coat of wet sludge. They come out of the machine, and the dry granules most of them are recycled, and some of them go to this dehydration unit. The specialty of this test was that we wanted to get out of the machine granules with a fairly low dry solids content. Normally we make 90% dry solid pellets or granules. Here in this test we wanted to have 65% dry solids, because this was required by the next step in this dehydration unit. In order to, first I will talk about the second step. The dehydration unit is a machine called, or a technology called Thermoloop by here Valsafe, a UK company, which was one of the partners in the team. And in 2 words, it is like a batch type evaporation system whereby the hot air is recycled through a heat exchanger, and the heat from the condensing stage is with a heat pump used to preheat the air that is recycling through the dryer. There's also an amount of fresh air, of course, an amount of condensation that is taking place inside the machine. So this was a quite new technology that has been used for the first time in this project. Here you see an artist impression of this dehydration unit. I didn't find a picture yet, I'm sorry for this. Here you see our granulator, so our Putard technology in small scale. We call it then the Lilliput. This Lilliput here in mounting in the wastewater treatment plant of United Utilities in Ellesmere Fort near Manchester. I will have a small intermezzo about our technology Putard. This is how the dryer itself looks, and this is one reference plant we have built with this technology in Poznan in Poland several years ago. The machine is a vertical structure. I think there's some more extra information. It's a vertical structure which is cold, and inside is a number of trays which are heated with thermal oil or steam, and the sludge is drying, is rolling actually. These granules are rolling on top of the trays and are moved by a system, a mechanical system with a central shaft and arms that are mounted on that shaft. Again, if you want more details, you can always contact me after this presentation or after this session. This is the machine again during mounting on site at the wastewater treatment plant of United Utilities near Manchester. And these are the first granules in the hands of my colleague who was operating this unit at that time. And this was about 1 year ago in November of 2012 and December. You see it as a test unit because it's temporary scaffolding and so on, and temporary equipment. In the meantime, the plant is being decommissioned and is brought back to Belgium. The capacity of this unit was 10 tons per day of evaporation, so in sludge drying this is a very small unit, and the objective of it is to dry to 90% thresholds. The last step of the project of END-O-SLUG was to improve the market development of the products that we have made, so this organomineral fertilizer. The aim is to develop a distinct knowledge base by which farmers and agriculturalists can integrate this organomineral fertilizer product. And there are two different products being developed, so depending on the NPK ratio and the target of this. And the market demand was a key factor in gaining this end of waste status. So this again is a very specialized part of the project, and in order to do this, there will also field trials have been held in the UK to see how good this organomineral fertilizer compares to traditional standard fertilizers from the industry. And as you can see, the result is that this product is equal in result. So depending on the type of plant, wheat or grass or whatever, oilseed, you can see that the organomineral fertilizer has equal or sometimes slightly better results than standard. This test was mainly the work of this gentleman, Mr. Sakrabani, again of the UK. Practical steps then in the end of waste status. The product status, of course, instead of the waste status, is the key aim of this organomineral fertilizer development. It's a complex issue, and this work, I believe, is still going on. We are not yet at the conclusion of this work. The project is for 3 years and is scheduled to end in the middle of next year. The market development has also been evaluated, so to find a sustainable and renewable source of phosphate. The OMF has the potential to fulfill these market requirements, and unlike UK, the application of biosolids to land is not universally accepted by all the stakeholders. For example, in the Netherlands, as you have already seen from Professor Menini, recycling to land is simply forbidden or prohibited. And the END-O-SLUG project is working hard to address these issues of acceptability. So, conclusions. END-O-SLUG aims to create a portfolio of useful new products and technologies from sludge that meet end-of-waste status as part of a new concept for sludge management in Europe. And this involves the development of new technologies for sludge volume reduction, the more efficient sludge treatment, the economical downstream processing of sludge, and the renewable source of phosphorus that could sustainably support crop production. The results so far are promising, not on all aspects, but most of them are very promising, and conclusions are to be expected in the middle of next year. For more information, you can consult the specific project website www.end-osludge.eu, and here you have the contact details of the project manager, Dr. Le of United Utilities, and also my contact details. So this project is part of the 7th framework program FP7 of the European Union.